Section 11.6 has a lot of formulas in it. We're going to see the probability of finding an event that does not happen. Then we're going to discuss probability when we see the word or in our word problem. And then by the end of this video, we're going to talk about the odds. The odds are a little different than just probability. So starting with the not formula, the probability that event E does not happen is you're going to start always with the number 1, and you're going to subtract the probability that the event does happen. So 1 minus the opposite, which is that the event E does happen. So looking at example 1, you select one card from a standard deck of cards. What is the probability that you do not select a queen card? What's nice about this formula is that it's easy to see when we can implement it. Whenever you see the words probability and the word not in the same sentence, that's your cue that you can use this formula. We're only ever using the right sides of any of these formulas in this chapter, so I'm going to focus on the 1 minus the probability the event does happen part. Yes, there are other ways you could get the right answer with the word not, but I'm just going to use this formula. So we want in example 1 the probability of not selecting a queen card. So we said as soon as you see the word not, the right side always begins with the number 1, and we subtract the opposite. The opposite of not getting a queen is that we do get a queen. So 1 minus the probability we do select a queen card. So bring down the 1 and the minus. Probability, whenever you throw down the P for probability, think fraction. What we want, divide by grand total. We want a queen. There are 4 queens in a deck of cards. Queen of hearts, queen of diamonds, queen of clubs, queen of spades. If you are not familiar with cards, please feel free to print out the deck of cards handout that I have put into our Canvas course. You're welcome to print that out and use it even on the test. You can bring it with you. But there are 4 queens in a standard deck of cards, and there are out of 52 total cards in a standard deck of cards. So 4 over 52 is the probability we do get a queen, and now we want to subtract that from 1. I'm going to make the graphing calculator do this calculation from here. Putting this into the graphing calculator, we have 1 minus, then we had 4. Remember, fraction bar just means hit the division button, so divided by 52. We want a fraction, a simplified fraction as the final answer, so I hit the math button, third one down on the left side. Frac, it's already highlighted, ready to go, so math, frac, enter. And we see the final answer is 12/13. So, final answer we said is 12 over 13. For those of you not using the graphing calculator, you would have to do this longhand. Remember, when we subtract fractions, we have to first have the same denominator. So what you would do is you would put the whole number 1 over 1 to make it into a fraction. And then to make it have the same denominator as the other fraction, you would have to times the top and bottom by 52, which was the other fraction's denominator. And bring down the minus 4 over 52. I haven't touched that yet. So I have 1 times 52, which is 52, over another 1 times 52, which is 52. Bring down the rest. So really, I would just rewrite the number 1 as 52 over 52. Once the denominators are the same, then we can subtract across the tops, the numerators. 52 minus 4 is 48. Leave the denominator the same, which was 52. Then you just have to reduce 48 over 52. 4 is the biggest number that divides in evenly without a remainder into 48 and 52. So when I divide the top and bottom by 4, ta-da, I get the same exact final answer, because 48 divided by 4 is 12 on the top, 52 divided by 4 is 13 on the bottom. But as you can see, it's a lot more work, it's more time consuming if you are going to do this longhand, so please feel free to just use the graphing calculator if you so want to do so. Looking at example 2. Example 2 says you select one envelope from a stack of 5 blue, 7 green, 6 red, 1 yellow, and 1 purple. Assuming all the envelopes are the same size and shape, meaning you have the same chances of grabbing any one of them, what is the probability that you do not select a green envelope? So I see the words probability and the word not in the same sentence. So I can use my not formula. So I do not want a green, meaning I'm happy with any color but green. The right side of the formula always begins with the number 1. We're always subtracting. The opposite. So the opposite of not green is that you do get a green envelope. So I'm going to really do 1 minus the probability of getting a green envelope. So bring down the 1 and the minus. Probability means fraction bar. If you're calculating the opposite probability first, that you do get a green envelope, there are 7 green envelopes. What we want, divide by grand total. So we wanted green divided by grand total. It does not give us the grand total, so we need to add all the envelope colors together ourselves. We had 5 blue, 7 green, 6 red, 1 yellow, and 1 purple. So I'm going to do 5 plus 7 plus 6 plus 1 plus 1. And when you do that, you do get 20 as the total here, 20. So 7 green out of 20 total envelopes. And now you can just put it into the graphing calculator. I will let you guys try this on your own, but just try it. Remember, it's math button, frac, enter, or do it in your head, whatever you prefer, but you should be getting 13 over 20 as the final answer. If you don't get this answer, please make sure you're remembering to type in the 1 minus first in front of that 7/20th fraction there. But 13 over 20 is the final reduced answer. By the way, if you are looking for this example in my face-to-face note packets, which I've uploaded into our Canvas course, this example too I actually did not put in my face-to-face lecture note packet. So this is a brand new example that I put into this video because I noticed there were a bunch of envelope probability questions in the MyMathLab homework. Example 1, there's a similar question. It's worded just slightly different, but it is in the note packet. It's in around the middle of section 11.6 if you are searching for that. The next formula is how to calculate probability when you see the word or. So the probability event A happens, or event B happens, or both. This is the inclusive or we can always assume in this course. So we're happy with one or the other or both is what that or means. To calculate this probability, we're going to first figure out the probability that event A happens. Then we will add it to the probability event B, the other event, happens. However, once we add those two probabilities, as we'll see with the examples, there a lot of times is overlap, and we've double counted that overlap, and we don't want to double count anything, so we then have to subtract the overlap. So event A and event B. So what happens simultaneously, or a lot of students remember it as both, minus the probability of both events, in other words. So keeping this formula in mind, let's take a look at example 3. The numbers 1 through 10 are written on pieces of paper and placed in a hat. One piece of paper is randomly selected. Determine the probability that it is an even number or a number greater than 6. So as I'm looking at this word problem, I see that the word probability is in the same sentence as the word or, so that's how I know it's time to use our new formula. You will literally see the word or every time in that probability sentence. So we want the probability that we get an even number or a number that's greater than 6. I'm going to use the greater than symbol, which is an arrow pointing to the right. I promise that's not just my messy handwriting trying to draw a 7. It's supposed to say number and then that greater than symbol, 6. So according to our formula, we first find the probability of the first event, A. So the first event described was even number. Then we will add it, according to the formula, to the probability of the second event described, which is that the number is greater than 6. Then we subtract it to A and B's probability. In other words, both an even number that's also greater than 6. For this formula, and actually for all the formulas in this entire chapter, we only really care about the right side. So that's what I'm going to focus in on. The right of the equals symbol, in other words. To the right side, I see we have 1, 2, 3 P's. So 3 probabilities that we really need to calculate every time we use the OR formula. Every time I see a P on the right side of the equals symbol there, I'm going to draw a fraction bar. So I'm going to write fraction bar, bring down the plus symbol, another fraction bar, bring down the minus symbol, fraction bar. So from here on out, whenever I do an OR probability example, I will be writing fraction bar plus fraction bar minus fraction bar. The denominator of all 3 fractions will always be the same in this formula. The grand total, well, we're talking about the numbers 1 through 10. So there are 10 total numbers to choose from. We're going to use the phrase above to get the numerator. So the first phrase is even numbers. If I think about all the even numbers, since we're talking about the numbers 1 through 10, that would be 2, 4, 6, 8, and 10. Even meaning divisible by 2. So there are 1, 2, 3, 4, 5 total even numbers out of 10 total numbers. So the probability you select an even number is 5 out of 10. Now, I look at the next probability. It says numbers greater than 6. So that would be 7, 8, 9, and 10. Notice it does not say or equal to 6, so we're not going to include the actual number 6 itself. We want all the numbers in the sample space, which are the numbers 1 through 10, that are strictly greater than 6. So that's 7, 8, 9, 10, which would be 1, 2, 3, 4 total numbers that qualify. So 4 out of 10 is the probability you choose a number greater than 6. By adding these outcomes, these probabilities together, what has happened is that we have double counted some of the numbers. So that's why we always have to subtract any overlap. So I have the probability of both, in other words, the numbers that are both even and bigger than 6 at the same time. So that would be 8 and 10. So there are two numbers out of the 10 that were both even numbers and also greater than 6. Those are 8 and 10. We're subtracting away the extra count that we got when we added those probabilities together initially. So now for my computation, we have 5/10 plus 4/10 minus 2/10. Notice that I did not reduce any of these fractions. Why? Because I'm about to throw it in the calculator and make the calculator reduce the final answer anyway. So there's really no need yet to reduce any fractions. You could do this longhand. After you add and subtract the fractions, if you are doing it longhand, that's when you would finally reduce the top and bottom. If there is a number besides one that divides into the numerator and denominator, you would do so to reduce it. I'm going to bring up my graphing calculator screen and show you how you would type in all these fractions. So we had 5 divided by 10 plus 4 divided by 10 minus 2 divided by 10. Notice I did not reduce any of the fractions yet. That way I can just throw it in the calculator. The calculator is going to reduce it anyway. And then we hit the math button, frac, enter. 7/10 is the final answer. So 7/10. Final answer for example 3. Now looking at example 4, it says one card is selected from a standard deck of 52 playing cards. Determine the probability that the card selected is A, an ace, or a heart. So I see probability with the word or in the same sentence, so it's time to use the or formula yet again. And for the sake of room, I'm really just going to write the right side of this formula. That's the important part anyway. The probability event A happens plus probability event B happens minus the probability of both. So putting it into the context of this question, first we're going to find the probability that we get an ace plus probability the other event is a heart minus the probability of both an ace and a heart. You may want to print out the deck of cards handout I've uploaded into our Canvas course. You can even bring it with you on test day and use it. But that will help if it's been a while since you've used cards for this type of a question. Step 2, just like above, that's where I draw all the fraction bars for all the p's there. So I'm going to write fraction bar, bring down the plus symbol, fraction bar, minus fraction bar. The denominator this time is 52 since there are 52 total cards. Using the phrase that would normally be directly above the fractions if I had more room, but the first fraction there relates to the probability of getting an ace. We are counting all the aces, red and black, for now. So all the aces, that's all the A's. There are 4 aces you'll see on that deck of cards handout. Ace of clubs, ace of hearts, ace of spades, and ace of diamonds. So there are 4 out of 52 chance you would scoop up an ace. Plus, moving on to the next fraction, the probability you get any heart. Well, there are 13 hearts because there are 13 cards in every suit, ace through king. So the probability you get a heart card is 13 out of 52. Minus the probability of both, a card with both an A for an ace on it, as well as a heart. Well, there is one card, and that is the ace of hearts, that has both an ace picture and a heart on it. So there's one card with both qualities on it out of 52. You can then either do it longhand You can add and subtract fractions, remember, as long as the denominators are the same, and they are, and then you would reduce the fraction from there. Or you can make the graphing calculator do the work. So typing that in, we had 4 divided by 52 plus 13 divided by 52 minus 1 divided by 52, math button, frac, it's already highlighted, so I can just hit enter right on it. Enter a second time, and 4/13 is the final reduced answer. So jotting that down, we got 4/13 final answer for A, an ace or a heart or both. 4/13. Okay, so now I'm looking at B, and I have 0 room here, so I'm going to have to write on the bottom of the screen and then erase and remove my answer up after I do that. But B says the probability you get a red card or a black card. So first you'll figure out the probability of drawing a red card, then you'll add it to the probability of selecting a black card. Then you'll subtract the probability that you have both colors on the same card. Step 2, fraction bar plus fraction bar minus fraction bar. Every time you see the word or with probability, you have those 3 fractions. The denominator is going to be 52 again of all the fractions. First fraction, probability of selecting a red card. There are 26 red cards in a standard deck of cards. Half the deck, so half of 52 are red, so that's 26 would be half of 52, or you can think of it as 13 hearts plus 13 diamonds for 26 red. The other half of the deck are black cards, so the other 26, 13 clubs plus 13 spades makes 26 black cards. Minus both red and black colors on the same card. Doesn't even make any sense. You're not going to have 2 colors on the same card, so that's 0. 0 is always the probability for something that will never ever happen. 0 divided by 52 is really just 0 again. It's okay to have 0 on the top of a fraction in math, I just can't have it on the bottom. So minus 0. So really I'm doing 26 over 52 plus 26 over 52. If you're doing that longhand, that's 52 over 52, which reduces down to 1. So after all that, final answer is a whole number for a change of just 1. So I'm going to erase and move that answer up. Now this was a unique question in that you did not have to use the OR formula. You could have logically figured out the answer a lot quicker. Because remember, whenever you say in probability the final answer is 1, really what that answer means is that you are 100% guaranteed it's going to happen. So in probability, whenever something is definitely going to happen, final answer is always just 1, the whole number 1. And if you think about it, if you're selecting one card, and they're saying, what's the probability that that one card is red or black? Well, it's definitely going to happen because those are the only 2 colors on standard decks of cards. It's got to be a red card or a black card. It's got to be one or the other. So 1. And then finally C, same question, but this is still example 4. They want the probability, but now they want a picture card, which really means the same as a face card, or a red card. So let's set it up. We see the word or, so we know to use the same formula. So first we're going to figure out the probability of selecting a picture card. Then we're going to add it to the probability of selecting a red card minus the probability we have both a picture card that's also a red card. Step 2, get those fraction bars going. So fraction bar plus fraction bar minus fraction bar. The denominators, whenever you're talking cards, 52 is the grand total on the bottom. So then we just have to know what picture cards means. Picture means what literally has a picture of a face on it. So the aces are not picture cards. Picture cards are the jacks, queens, and kings. There are 12 picture cards. So if you're looking at that deck of cards handout, you'll notice there are 4 jacks plus 4 queens plus 4 kings for 12 total picture cards or face cards. Plus probability of red cards. We already said in part B there are 26 red cards in a standard deck of cards because 13 hearts plus 13 diamonds. Minus how many cards are both picture cards and red cards? Well, we said the picture cards are the jacks, queens, and kings. And the jacks, queens, and kings that are also red would be the jack, queen, and king, all of hearts and diamonds. So we have 2 red jacks, 2 red queens, and 2 red kings. Again, so that's jack of hearts, jack of diamonds, queen of hearts, queen of diamonds, king of hearts, king of diamonds. So there are 6 picture cards, face cards, that are also red cards, that are also hearts and diamonds. Hard part is now over, so now we just add it up. So when we do the calculations, you could just throw it into the calculator. If you're doing it longhand, we would start by keeping the denominator the same of 52 when you add and subtract fractions. 12 plus 26 would be 38. 38 minus 6 would be 32. This is definitely going to reduce further. So 32 divided by 52 is going to reduce to 8/13 because the top and bottom are divisible by 4. 4 divides in evenly with no remainder, in other words, into the top and bottom here. So we get 8/13. Or you could just throw the whole line into the graphing calculator, math button, frac enter. Either way, you're going to get 8/13. This slide is going to be more practice with the OR formula. These 2 examples, examples 5 and 6, if you're trying to locate these examples from my face-to-face lecture note packets, which are uploaded again in our Canvas course, these 2 are actually located in the extra practice section, which is near the end of that entire packet. So the last 2 pages would be where to look if you are following along on that face-to-face note packet from our Canvas course. So starting with example 5, there are 30 chocolates in a box, all identically shaped, meaning you have the same likelihood of grabbing up any one of those chocolates. 5 are filled with coconut, 10 with caramel, yes, I say caramel and not caramel, and 15 are solid chocolate. You randomly select one piece and eat it. Find the probability that you select a caramel-filled or a coconut-filled chocolate. Now, they love using food examples in the My Math Lab. You will most likely see very similar example about the chocolates. You're also going to encounter a donut, a few donut examples. But whenever you see that phrase, probability, with the word or in the same sentence, you can use that or formula yet again. Looking at just the right side of the formula, we first find the probability of the first event, which was a caramel-filled chocolate. We add it to the probability of the other event, which is a coconut-filled chocolate. And we subtract both. You get a caramel, and at the same time, it also has coconut in it. Second step, I draw the fraction bars for this formula. So that's 3 fractions, fraction bar plus fraction bar minus fraction bar. The total, grand total on the bottoms of the fractions, 30 total chocolates in this box. The phrase above dictates the numerators. So starting with caramel, there were 10 caramel filled. So 10 out of 30 was the probability you get a caramel filled. Coconut, there were 5 with coconut. So 5 out of 30. Remember, don't reduce the fractions yet because you're just going to throw it in the calculator anyway in a minute. And then finally, minus both caramel and coconut. That does not make any sense in this example. There was no mention of both fillings within the same chocolate. So when something does not make sense, when it's never going to happen, it's just 0 in probability. And 0 divided by 30 is really just 0. So actually you're doing 10/30ths plus the 5/30ths, which would be 15 over 30, which reduces down to 1/2. Makes sense if you think about it. So 1/2 of the candies in the box have either caramel or coconut filling, and then the other half are the solid chocolate. But 1/2, final answer for example 5. And now example 6 talks about marbles being selected. It says 1 marble is drawn from a box with 3 yellow, 2 green, 2 red, and 1 blue. Find the probability of drawing a red marble or a green marble. So again, I see probability with the word or in the same sentence. I'm going to use the same exact formula. So first we'll calculate the probability we select a red marble, plus we'll calculate the probability of drawing a green marble, minus the probability of selecting red and green at the same time, or both colors. Now we draw the fraction bars. Fraction bar plus fraction bar minus fraction bar. The grand total they did not give to us, so we need to take a quick sec and add everything together ourselves. There were 3 yellow, 2 green, 2 red, and 1 blue. So when I add those up, 3 plus 2 plus 2 plus 1, I see there are 8 total marbles to choose from. So 8 is going to be the denominator. Now using the phrase above to get the numerators, the number of red, there were 2 red. Number of green, there were also 2 green. Minus both colors, that does not make sense. There are 0 that were both red and green at the same time. 0 divided by 8 cancels to 0. We're going to do 2 8s plus 2 8s, which is 4 8s, which reduces yet again down to 1/2, coincidentally. So in other words, half of the colors were red or green. So 1/2 is the probability you get either a red or a green marble when you select one marble from that box. The third formula in this section deals with finding the odds. To find the odds in favor that the event E does happen, you'll first figure out the probability the event happens, and then you'll divide it by the opposite, which is that the probability the event does not happen. So odds in favor, when you see the words odds in favor, take the probability the event does happen and divide it by the probability the event does not happen. So you're dividing opposite probabilities. To find the odds against something happening, it's the same exact formula as odds in favor of, but it's just flipped upside down. So odds against, you'll first find the probability the event does not happen, and you'll divide that by the probability the event does happen. It's not as bad as it sounds. You just have to be careful when you put either formula into the graphing calculator, because there are 2 probabilities involved, 2 p's. That means you're really taking a fraction and dividing it by another fraction. So I'm going to put parentheses around the fraction bar and parentheses around that fraction bar. So for either odds formula, you're going to have a fraction divided by another fraction, and you absolutely need those parentheses around the top and bottom fractions to get the right answer in the graphing calculator. So to show you what I mean by that, looking at example 7, you are dealt one card from a 52 card deck. Find the odds, A, in favor of getting a red queen. The odds in favor of getting a red queen. So odds in favor was the top formula, and as usual, we only really care about the right side of these formulas. So we're going to calculate the probability the event does happen, and we'll divide it by the probability the event does not happen. So probability that we do get a red queen, and we divide it by the opposite, which is not getting a red queen, meaning any card but a red queen. Okay, so I draw my fraction bar, and remember we should have parentheses around the fraction on the top and on the fraction on the bottom. So let's start with the top, the probability we do get a red queen. Well, how many red queens are there in a standard deck of cards? There are 2 red queens, the Queen of Hearts and the Queen of Diamonds, out of 52 total cards in a standard deck of cards. So the probability you get a red queen is 2 out of 52. Now let's take care of the bottom fraction, the probability you do not get a red queen. So anything but, well, if there are 2 red queens, 52 total cards minus the 2 that are red queens means there are 50 cards that are anything but a red queen out of 52 total cards. You can check to make sure at the very least you're on the right track, because if you add the 2 numerators together, 2 plus the 50, you should get the bottom number, which is 52. If it's been a while since you've used cards, just to kind of refresh your memory here, so we said there are 2 red queens, Queen of Hearts and Queen of Diamonds, out of 52. When we take away the 2 red queens, there are 50 cards left out of 52 for the probability of getting anything but a red queen on the bottom. So now it's just a matter of putting it into the graphing calculator. We said we do need parentheses around the top and bottom fractions for either of the odds formulas. The parentheses are located above the 8 and the 9 keys. So we had parentheses, 2 divided by 52, close the parentheses, divided by parentheses, 50 divided by 52, close the parentheses, math button, frac, enter, and 1/25 is the reduced fraction answer. However, they want us to format this answer a little bit differently when they ask for the odds. So we got 1/25. Whenever they ask you for the odds, you're going to see in the My Math Lab homework an answer box, then a colon, and another answer box. We read the colon out loud as the word 2. So all you have to do is whatever the numerator is in your answer, type that in first. So it was a 1 here. Whatever the denominator is, type it into the second box. So it's like you took that fraction and you flicked it on its side. So 1/25 is the final answer. That's the odds in favor of getting a red queen are 1/25. Type the 2 numbers into those answer boxes on either side of the colon in the My Math Lab. So if that's the odds in favor of getting a red queen, we already know what the odds against getting a red queen are going to be for B. You know what the odds in favor of that scenario is. You just take the answer and flip it around. So then 25 to 1 must be the final answer of the odds against getting a red queen. If you want to work it out longhand, then you would use the odds against formula, where you take the probability the event does not happen and you divide it by the probability the event does happen. So you take the probability of not getting a red queen first, and you would divide it by the probability that you do get the red queen. So whenever it's the odds against, you figure out the not probability first, and that's what goes on the top. So just moving my divider over here to create more room. You'll still have a fraction divided by another fraction. 52 total cards and a standard deck of cards still, so that'll still be the bottom numbers. And now not red queen, meaning anything but. Well, there are 50 cards, as we already mentioned in part A, that are anything but a red queen, which means there are 2 that are red queens. Queen of hearts, queen of diamonds. When you punch this into the calculator, parentheses and all, you are going to get a whole number of 25 out. You have to rewrite any whole number as a fraction for the odds. So you would have to put that 25 over 1. That way you can type in the numerator first, 25. They'll already give you the colon in the middle, and then the 1 last. So that's how you get 25 to 1 as the final answer, doing it longhand, of the odds against getting a red queen. Let's do one more of these odds questions. So example 8, a single die is rolled. So die, that's singular for dice. Keep in mind with dice, there are typically 6 sides with each of the numbers 1 through 6 on a side. Find the odds against rolling a number greater than 2. So odds against, we calculate the probability the event does not happen first. So we don't roll a number greater than 2. I'm going to use a greater than symbol here. So that's not a 7. I promise that's me trying to draw a greater than symbol. It's not greater than 2. And then we divide it by the probability the event does happen. So we do get a number greater than 2. So we said for all these odds questions, we will have a fraction divided by another fraction with parentheses always in the calculator around the top and bottom fractions. So looking at the top, a number on dice that's not greater than 2. Well, what's the opposite of being greater than 2 would be what's less than or equal to 2. So the number 1 is not greater than 2. It's actually smaller than 2. And the number 2 itself is not bigger than 2. It's equal to it. So everything less than or equal to, which would be 1 and 2. So there are 2 numbers, the numbers 1 and 2, so 2 outcomes that are not greater than 2 out of 6 sides on standard dice. Now on the bottom, the numbers that are greater than 2 on standard dice would be 3, 4, 5, 6. So there are 4 numbers, 4 outcomes out of 6 sides that have a number bigger than 2 on them. Remember, make sure you're on the right track. When you add the 2 numerators, you should get the denominator. So 2 plus 4, yep, I do get the bottom number of 6. You're going to type that into your calculator, parentheses, around the top and bottom, or else the answer is going to be wrong. And after you hit math frac, try it. You should be getting 1/2, which you would type that into my math lab as 1. They'll already have the colon there, and then 2. So the final answer, I would read this out loud, is 1 to 2, 1 to 2. For odds against rolling a number greater than 2.